Hello guys, welcome back to my channel. In the previous video, I showed you how to import the third-party Spice model into our LT Spice schematic. So now in this video, I would be going to show you how to design an non-inverting OPAMP amplifier. So let's start. As you all know, that amplifier is a very common circuit that is used in many applications. So there are two methods or more than two methods that can be used to design an amplifier. The first method, that is a very basic method, is by using a transistor, a very common NPN or PNP transistor. And in my previous videos, I showed you guys how to design common collector, common emitter, common base amplifiers using transistor. Now in this video, I will show you how to design an operation amplifier based non-inverting amplifier. So let's place an OPAMP symbol in our schematic. Now we are going to choose operational amplifier model. Okay, so in our LT Spice library by default, there are various OPAMP models already available. So we can randomly choose these already available models, Spice models in LT Spice, or we can use a generic OPAMP, as I have put this OPAMP symbol here, and upload its Spice model from a third party vendor like Texas Instruments or Analog Devices website. So just like in my previous video, I would upload the Spice model into our schematic, and I would write a Spice directive again, dot include and place the directory path into the Spice directory. This is my directory path in which the model is placed, and I will copy this path and paste it here, slash OPA1656.lib. Okay, we are going to use this model OPA1656.lib because this model is with extension .lib. Okay, although it is showing an LTM.library model, but it is actually not the LTM library. This is the LT Spice library. So we would use .lib into our model. Here we have imported. Now we are going to use the circuit design of non-inverting amplifier. A non-inverting amplifier is an amplifier in which the input is given at the positive terminal of the OPAMP. You have to remember this. This is very important. And on the negative pin, we have a feedback resistor to the output. So let's place a resistor on the negative terminal. This is the feedback resistor. Okay, and another resistor is connected on the negative terminal again, and this resistor would be going to ground. This is the ground connection, and we would use a voltage source on the input side, that is positive input side. This is because it is the non-inverting amplifier. Now place ground on the voltage source, that is signal source. Right click on the voltage source, click advance and select sine. Sine wave we are going to input at the positive terminal of the op-amp. Let it be 0.01 volt peak, that is 10 millivolt peak amplitude signal, and let the frequency be 1 kilohertz. Okay, and we are going to use a transient simulation, so that would be enough. We will do the transient analysis. Okay, now we are going to use the supplies. So here is the battery. Let's take it 12 volt and copy this battery and paste again to make it a dual supply source. This common terminal is common ground and this is the positive, as we did in our previous video. VCC plus 12 and EEE minus 12. Okay, this is minus 12 EEE and this is plus 12 VCC. Now we are going to copy these nodes into our positive terminal of the op-amp and on the negative supply terminal of the op-amp, that is plus VCC and minus EEE. Now one thing I forgot to add here is this OPS 1656 name here. So I'm going to open this model first of all. Just remember to use this name, the name which is written as with the sub-circuit line. This is the name which you will be using in your schematic draft here. 1656.2. Okay, now everything is okay. Now let's use the resistor equal to 10 kilo. You can choose any value. I am going just to show you how the amplifier works. 10 kilo ohm. Both resistances are equal to 10 kilo ohm. Why? Because the formula of the non-inverting amplifier gain is 1 plus RF upon RI. This is the formula, and this is RF, that is feedback resistor. RF is the feedback resistor and here feedback resistor is R1. Therefore this is 10 kilo ohm, so 1 plus 10 kilo ohm upon this is the input resistance Ri, which is this input terminal is grounded with this resistor, therefore it is Ri, and it is also 10 kilo ohm. Therefore 10 kilo ohm divided by 10 kilo ohm makes it 1, and 1 plus 1 equals to 2, so the gain would be equals to 2. So our sine wave is 10 millivolt, therefore our signal would be equals to 20 millivolt peak. Let's place an output node. So our signal would be amplified 2 times. Now let's see if this happens. Our circuit is complete. Let's make a transient simulation of 10 milliseconds. And this, here is our output and here is our input. So yes, the output is amplified 2 times. Let's check it. Here is the peak. And here is the reference 0 millivolt, 0 volt. Therefore, our output is going to be equal to 21 millivolt or equals to 20 millivolt, because I have not placed the cursor exactly on 0 millivolt. So this is 20 millivolt peak. Okay. Or you can see the difference between the peaks of input and output. This is also the way to check the amplification. This is 10 millivolt our input, 10 millivolt, and this is our output, 20 millivolt. Okay, so the gain is equal to 2. I hope you enjoyed this video and learned about non-inverting amplifier. And yes, one thing I forgot to mention is that both the input and output are in phase with each other. In a non-inverting amplifier, both input and output are equal in phase, while in inverting amplifier, the output is 180 degree out of phase with the input. In the next video, I will show you how to design a inverting amplifier. See you in the next video, guys. Take care. Bye bye.